Okay, welcome back. So now I want to go over something with transformations that is important to know and understand and trip students up. So the idea is again, what happens to x and y in a transformed function, right? When it comes to the y direction, students don't have a problem with that. If you add outside of y, right? So if you're adding to the function outside the function, then you're going up, right? All of the y values are shifting up. If you subtract outside the function, then you're moving all the y values down. If you multiply by a real number, right, that's bigger than 1, then it's going to be a horizontal stretch, or excuse me, a vertical stretch, right? And if you multiply by a number between 0 and 1, then it's a vertical compression or shrinking, right? That's easy to understand when you're dealing with the y's, right? When you're dealing with what happens with the x's, it's less intuitive. It's actually opposite of what you would think. When you're dealing with y's, it's exactly what you would think. With with inside the function, it's opposite what you think. And so to help you kind of visualize or help understand what's going on, I just took a basic function f of x equal to x squared, and let's define a transformed function g of x equal to this, right? So it's a transformation of f of x, right? So let's just focus on what's going on inside the function. That's where students mess up. Okay, so let's forget about the 2, let's get rid of that, and let's just make it this, right? And so let's say we want to know, hey, how does the transformation affect this point? Well, we know on the parabola for f of x equals x squared, the point 1, 1 is right here, right? So we want to know, hey, where does the point move to? And again, we're just affecting x in this case. Where does the point move to for g of x, right? To sketch the graph of g of x, all we need to know is the behavior of f of x, how to sketch f of x, and then what happens to the points, right? So in this case here, let's say what happens to this point here. Now, if you look here, we know, right? We know that so we know this. We know f of 1 equals 1, right? We know that. We know f of 1 equals 1. But now we've got g of x, and now we want to know, hey, where does this point move to for g of x? Okay? And so in order to see that, what we do is we say, okay, well, we know f of 1 is equal to 1, and we're trying to figure out what happens to that value when we have this transformed function. So the idea is, okay, well, what if we just say, okay, we know what happens when this is equal to 1, right? So in other words, think of this is our original x, and now this is our new x coordinate. So what value of x do I need in order for this whole thing to be equal to 1? So all I have to do is set 3x minus 1 equal to 1 and solve. And so if I solve, I get x equals 2/3. And what happens is that's my new coordinate. That's my transformed coordinate. So I know that this point at 1, 1 for f of x moves to what? It moves to 2/3, comma 1 for g of x. So this point moves over a little bit to the left. Okay? Now, here's the thing. Let me just say this. So again, when I talked about thinking about in opposite terms when you're dealing with x, just think about this. What happens? Well, if I'm at 1, right, so we're talking about x. If I'm at 1, okay, This is unchanged, but if I'm at 1, what's going on here? Well, I'm moving to the right 1 spot, right? So I'm moving to the right. Okay, so I'm subtracting 1 here. So I'm going to move to the right 1 unit. So this is going to go from 1 to 2, right? So that's going to move to 2. And then I'm taking 1/3 of the value. So I'm just divided by 3. And there you go. Look at that. I got the same answer. Okay? That's how it works. That's why it works. Now, let's take an example here. Let's just say, okay, you've got this example on a homework problem or whatnot, and what we're given is, let's say we're given a point, 3, comma -5. And we're given a function f of x. And we know that, we're told that, we know that f of 3 equals -5. Okay, so we know that this point is on the graph of f of x. So that's what this tells us. Okay, now, they tell us, okay, where does this point move to when we have this new function? Let's call this g of x. Let's call this g of x. And we want to know, okay, where does this point move to for g of x? Okay, in this transformation. So all you have to do is, okay, what happens to y? Y is easy, so let's take care of y. Okay, so what happens to y? Well, y, what are we doing? We're subtracting 1 from all the y values and multiplying all the y values by 3. So that's easy. We're going to subtract 1, which gives us -6, and then we're going to multiply by 3, which gives us -18. So that's the easy one. Now, what about finding what happens to 3? So where does 3 move to? Well, now this is where we're going to say, we're going to use this information. So we know f of 3 equals -5, right? So we know we start at 3. So we know that if the inside of f is 3, we know that that has to equal -5, right? So if we want to know what this point is, all we do is take 2x plus 4 and set it equal to 3. And this x value here is going to be where the point moves to. And so now I'm just going to solve for x. So I'm going to subtract 4. That's going to give me -1. So 2x equals -1. Now I'm going to divide by 2, and I get x equals -1/2. That's the answer. So -1/2. And so now, the point on f of x would move to this point for the transformed function g of x. And that's how you do it.